think about the modern aerial battlefield for a moment. It's not just planes versus planes anymore, is it?
Not at all.
You've got these incredibly sophisticated air defense systems. They can make operating even the most advanced aircraft, well, a serious challenge.
Definitely.
We've seen this play out, haven't we? Especially in recent conflicts like in Ukraine. Electronic warfare has become, well, absolutely critical.
That's a really crucial starting point. The ability to effectively deal with, maybe neutralize or, significantly weaken the enemy's air defenses. It's
It's
fundamental.
basically getting air superiority, right, and protecting your own forces.
Exactly. And this brings us neatly to a really fascinating development we're going to unpack today.
Right. We're diving deep into the British Royal Air Forces, the RAF's latest piece of tech. Their first autonomous collaborative platform, or ACP, is called StormShroud.
And for you, our listener, especially if you're preparing for the UPSC exams, this is a particularly relevant area. We're talking cutting-edge defense technology here.
Yeah. And shifts in international security. The very nature of warfare is changing.
Absolutely. These concepts we'll explore. They could be important for both your mains and prelims, potentially.
Good point. And all the information we're digging into today, just so you know, comes from a detailed report in the Eurasian Times.
That's our source, yes.
So, okay, our mission for this deep dive is pretty clear. We need to understand exactly what StormShroud is, how it works, and crucially, why its arrival is such a significant moment in military aviation.
Let's get into it.
Okay, let's unpack this. What exactly is StormShroud?
So at its heart, StormShroud is the RAF's very first autonomous collaborative platform, ACP.
Right.
The key word there really is collaborative. It's designed for what's called manned-unmanned teaming. MUMT is the acronym you'll hear.
Manned-unmanned teaming. Okay.
Yeah, think of it like a digital partner. It works alongside crewed fighter jets like the F-35B Lightning II and the Eurofighter Typhoons.
So it's not replacing pilots, but working with them? Like a wingman, but autonomous.
Precisely. It's a teammate. And the key insight here is that shift, moving away from relying only on human-piloted aircraft to a more integrated force. Maybe a more resilient one, too.
Makes sense. So what's its primary job on this team?
Its main function is electronic warfare, EW.
Ah.
Essentially, StormShroud is an electronic warfare drone. Its core mission, to act as a protector.
Protector for the jets.
Yes, for the RAF fighter jets.
Yeah.
By effectively neutralizing or degrading enemy air defenses. It's a proactive electronic disruption, not just reactive defense.
Which seems vital given how advanced those defenses are getting.
It really is. It's a crucial evolution in trying to counter modern integrated air defense systems, or IADs.
And you mentioned its development. It wasn't just cooked up in a lab, right? It's based on lessons learned.
Exactly. The RAF has been quite explicit about this. The design, the purpose of StormShroud, it's directly influenced by the realities of modern warfare.
Like Ukraine.
They specifically pointed to the conflict in Ukraine, and other events around the globe. So it's not just theory. There's a clear, demonstrated need driving this development.
So not just a concept, a real-world driver.
Absolutely. The RAF's broader strategy for these ACPs emphasizes this mix, crewed and uncrewed autonomous platforms. They see it as the most effective way to deal with increasingly sophisticated adversaries.
Makes sense. What are the main goals then?
Well, it's multifaceted. Greater adaptability, in fast-changing situations, enhanced agility in operations, and importantly, cost-effectiveness.
And reducing risk, I imagine.
Definitely. Reducing the inherent risks to human pilots when they have to go into highly dangerous areas. This kind of stand-in approach potentially lowers the cost and the risk associated with EW ops.
That must be a huge factor for pilots. So who's actually going to be operating these StormShroud systems?
Okay, so the responsibility for operating StormShroud will mainly fall to 216 Squadron, but with essential support from the RAF Regiment and other UK defense personnel. That includes members of the Royal Auxiliary Air Force, too.
So a dedicated unit.
Yes. And they're emphasizing that these personnel are getting specialized training to operate effectively in high-threat scenarios, often in small, highly mobile teams.
Sounds very specialized. And look, this isn't happening in isolation, is it? You mentioned other countries are looking at similar things.
That's right. This unveiling, it's part of a wider global trend. You see advanced militaries increasingly introducing what are often called loyal wingman type drones.
Loyal wing
Drones designed to work really closely in coordination with crewed fighter aircraft.
Okay, so StormShroud is kind of like an EW-focused loyal wingman. Let's delve a bit deeper into what it actually does. We understand it conducts suppression of enemy air defenses, SEAD. What does that look like?
Right. SCA. Suppression of enemy air defenses. In simple terms, it's like trying to temporarily blind and deafen the enemy's air defense network, so our aircraft can operate more safely. Essentially, StormShroud aims to make RAF jets much harder for the enemy to detect and track
Oh.
by using sophisticated techniques to, well, deceive or actively jam hostile radar systems. Think of it as creating a lot of noise and confusion in the electromagnetic spectrum.
So while other loyal wingman drones might carry weapons or do surveillance, StormShroud is all about the EW.
Exactly. That's the key differentiator here. While some other designs might mix in EW with other functions, StormShroud's defining characteristic, at least currently, is its sole focus on electronic warfare, specifically SEAD.
Okay, so how does this dedicated EW drone actually, work its magic? What's the tech inside?
Well, StormShroud is essentially a combination of two key systems. You've got the physical platform, which is the Tekever AR3 uncrewed air system UAS,
Tekever AR3.
and then it's equipped with the operational payload, which is the Leonardo BriteStorm Electronic Warfare Suite.
Okay, let's break those down. Tell us about this Tekever AR3 platform.
Sure. The Tekever AR3 is a tactical UAS, and it's got a significant real-world track record. It's been used extensively, and crucially, it's combat-proven in Ukraine.
Wow.
Accumulated over 10,000 combat hours there, so it's known for being reliable, adaptable, offers around 16 hours of flight endurance, and it's relatively compact, lightweight.
That combat experience is huge.
Yeah,
Choosing a proven platform suggests they're prioritizing reliability, right? Not just theory.
precisely.
Yeah.
It suggests they want something that works, based on real-world effectiveness.
Yeah.
A big factor when you're adopting new military tech.
Okay, and the other piece, the Leonardo BriteStorm system.
Right, the BriteStorm. It's described as a stand-in jammer.
Stand-in, what does that mean?
It means it's a relatively small, versatile EW system designed to fly ahead of the more valuable crewed aircraft, closer to the danger zone.
Oh, okay.
Its main job is to target those integrated air defense systems, the IADs. Think of IADs as that layered network of enemy radar and missiles. BriteStorm works by disrupting their ability to track and target friendly aircraft using their radar.
So it gets in close and messes with their radar picture.
Exactly. Mark Randall from Leonardo, he put it quite well. He said platforms with BriteStorm can deploy ahead to create confusion so that enemy IADs are unable to detect, track, and attempt to engage friendly assets.
Creating confusion. I like that.
And he stressed, with near-peer IAs getting so advanced, systems like BriteStorm are becoming essential for protecting your own forces.
Interesting. The article also mentioned it's different from traditional standoff jammers. What's the difference there?
Good question. So traditional standoff jammers are typically large aircraft. Think converted airliners or bombers. They operate quite far from the battlefield, maybe hundreds of miles away, and use sheer power to jam.
Right.
BriteStorm, being lightweight and on a drone, can operate much closer. This stand-in jamming approach, it means you don't necessarily need the same level of brute force power.
Because you're closer to the target radar.
Exactly. It makes it more suitable for engaging near-peer adversaries in closer proximity. Imagine standoff jamming is like shouting across a huge stadium. Stand-in jamming is like whispering right into someone's ear, potentially more effective with less overall energy. And of course, being drone-based, it's potentially cheaper and carries less risk to personnel than a big crewed jet.
Makes sense. So how does BriteStorm actually create this radar confusion? What's the tech?
Okay, so when BriteStorm detects an enemy radar signal, it digitally records that pulse. It analyzes its characteristics, frequency, pulse width, things like that, and then it responds. It can use advanced spoofing techniques or direct electrical jamming. This is powered by Leonardo's digital radio frequency memory technology, DRFM.
DRFM. That sounds important.
It's crucial. Think of DRFM as a really sophisticated digital mimicry system. It allows BriteStorm not just to block the enemy radar, but to actively confuse it by sending back very convincing fake signals.
Fake signals? Like what?
We can manipulate the radar returns to create numerous false targets, ghost fighter jets appearing on the enemy screen or other misleading signatures. It makes it incredibly difficult for them to tell what's real and what's not.
Wow. That's clever. But enemy radar tech is always improving, right? How does BriteStorm keep up?
That's where its software-defined architecture comes in. It's designed to be updated easily.
Ah, software updates.
Exactly. Allows for real-time or near real-time updates to the system's threat library and jamming techniques, so they can adapt rapidly to counter evolving threats. That adaptability is absolutely vital against modern IADs.
So who is involved in actually bringing StormShroud to life from concept to, well, this unveiling?
It was a collaborative effort. Several key organizations were involved. You had the RAF's Rapid Capabilities Office, the RCO,
Okay.
the Defense Equipment and Support DE&S Catalyst Team, the Defense Science and Technology Laboratory, DSTL, and various UK industry partners as well.
A real team effort then. And deployment, how do these actually get airborne? Are they launched from the F-35s or Typhoons?
Interestingly, no. Although they work with the fighters, they won't be carried by them, at least not in this initial configuration.
So how then?
They'll be launched from the ground using a portable catapult mechanism.
That's...
Yeah, and the crews are currently undergoing training for exactly that launch method. Now, the Tekever AR3 platform can be configured for vertical takeoff and landing, VTOL.
Right.
But the specific model the RAF displayed didn't appear to have that VTOL capability fitted. So, catapult launch for now.
That makes sense for ground-based flexibility. The CEO of Tekever, the company making the drone platform, he had some comments too.
Yes, Ricardo Mendes.
Yeah.
He emphasized that the primary goal for the AR3 in the StormShroud setup is really twofold. One, effectively carry that critical BriteStorm payload.
Get the jammer where it needs to be.
Exactly. And two, ensure its survival in really complex radio frequency environments, especially if it's operating as part of a drone swarm. The focus is on getting the EW capability there and making sure it works, even under electronic attack itself.
Survivability in that messy EW environment is key. So what are the bigger plans here? Is StormShroud just a one-off project for the RAF?
Oh, definitely not. The RAF has stated quite clearly they intend to acquire a whole fleet of these autonomous collaborative platforms. Yes, with potentially varying levels of sophistication and cost depending on the mission. They put an initial investment of $19 million into these advanced drones.
19 million pounds.
And that's also supporting about 200 engineering jobs in the UK, which they highlighted. So StormShroud is really positioned as the first in a whole family of these next-gen ACP drones coming to the RAF.
It's interesting. You hear comparisons sometimes with the U.S. program, the Collaborative Combat Aircraft, the CCA. Are they basically the same thing?
There are definitely similarities, yeah. The overall idea of collaborative combat drones working with crewed fighters is shared.
But
there are important differences, too. The U.S. CCA program, as currently envisioned, expects those drones to carry weapons alongside other sensors and EW maybe.
okay, armed drones.
Right. Whereas StormShroud, in its current form, is solely focused on that electronic warfare role. It's not carrying missiles or bombs.
Got it. Any other differences?
Yes. StormShroud is also noted as being smaller and probably less survivable, less stealthy, perhaps, than what's anticipated for the US CCA platforms, which are expected to be quite sophisticated, almost like mini fighter jets themselves.
So different roles, different designs, even if the core concept of collaboration is similar. Generally speaking, though, what are the advantages we expect from drones like StormShroud?
Well, broadly, these collaborative combat drones offer several key benefits. They provide additional combat effects, whether that's EW, sensing, or potentially weapons and other systems.
Right.
They can extend the sensor range of the manned aircraft, acting as forward eyes and ears. And crucially, they can undertake high-risk missions, going into heavily defended areas where you might hesitate to send a human pilot.
That risk reduction again. And just to reiterate, StormShroud's unique selling point, its niche right now, is that dedicated focus on EW, on SEAD, using that BriteStorm system.
Exactly. Yeah. Unlike some multi-role loyal wingman concepts you might see emerging, StormShroud is purpose-built for this critical electronic warfare job. That makes it a specialized and potentially very effective tool in the modern air power toolbox.
Okay, so to kind of pull this all together, StormShroud is the RAF's first autonomous collaborative platform. It's an EW-focused drone, combines that combat-proven Tekever AR3 airframe with the advanced Leonardo BriteStorm jamming system.
Correct.
Its development, driven by real-world lessons from modern conflicts like Ukraine, and its goal is basically to protect those expensive crewed jets by neutralizing enemy air defenses using sophisticated EW techniques.
That sums it up nicely.
Yeah.
And for you, our listener, especially if you're preparing for the UPSC exams, think about how this really illustrates that increasing technological sophistication of modern militaries.
Yeah.
And the absolutely critical strategic importance of electronic warfare in today's security landscape. Consider the implication for India's own defense strategy. What technological advancements might be needed to stay competitive in this evolving domain?
It really does highlight just how fast things are changing in aerial warfare. Okay, on that note, here's a final thought for you to maybe mull over. Given the effectiveness of electronic warfare we're seeing, demonstrated in recent conflicts, how might future military doctrines evolve? How will they adapt to both counter and leverage these increasingly sophisticated capabilities?
That's a vital question, really gets to the heart of future strategy.
We'd genuinely love to hear your thoughts on this and any questions you might have from our discussion. So please do like this, subscribe if you haven't, and definitely leave a comment below. Let's keep the discussion going.
Please do.
And just a reminder, the information we discussed today was based on reporting from the Eurasian Times. Thanks for taking this deep dive with us.